Thank you so much for joining us. My name is Kiran Mida. I am within the product marketing team here at Cognite. I'm a senior director here at Cognite. And with us, I'm very grateful to have Sebastian Winter from Verdantix as well, who's an industry analyst specifically covering operational excellence at Verdantix. And today we'll talk a little bit about unlocking the value of industrial data for operational excellence. So just a bit of housekeeping for everyone. Thank you again for joining us today, and we really do appreciate your participation. Duration of today's webinar is 60 minutes. This webinar is being recorded, and the recording will be made available on cognite.com. Please do post questions in the question box throughout the webinar as you think of them, and we will get to the questions towards the very end. Today's webinar consists of a presentation section followed by a Q&A. I will actually now hand off to Sebastian, and just prior to you going, Sebastian, I'll just sort of establish today's goal. The goal of today's webinar is to talk about scaling use cases in a digital twin context with contextualized connected data in Cognite Data Fusion, and of course talking about the underlying technologies as well. What are some of the challenges to get past or getting past the data challenges for operational excellence? Why industrially or IoT optimized data ops is needed for digitalization success, and what does data ops mean for heavy asset industries as an underlying technology? And with that, I will hand it off to you, Sebastian, and then we'll come back to me talking about Cognite a little bit later in the webinar.
Okay, thank you, Kiran. So hello, everyone. As Kiran mentioned, I am an industry analyst in Verdantix. Verdantix is an independent analyst firm. We cover 4 different verticals. These are operational excellence, which is the one that I'm sat in, environment, health and safety, ESG and sustainability, and smart buildings. My coverage within the operational excellence practice, I lead all of Verdantix's research into asset management sector, and I've also led our research for digital twins as well. So I'm going to talk today in today's webinar about unlocking the value of industrial data for operational excellence. And specifically, I'm going to focus on unlocking the value of industrial data through asset management software and how that requires users to liberate and contextualize data from multiple systems. And I'm really going to focus in on digital twins in the second part of this, where I'm going to talk about how digital twins for industrial facilities specifically unlock the value of industrial data. So just starting off with a definition of what do we mean when we talk about operational excellence. As you can see here, this is the Verdantix definition, which is that solutions that assist managers in operations, asset reliability, process safety, and maintenance roles to enhance production reliability, asset health, and operational safety. What does this really mean? Well, what we're focusing on are the services and software and other technologies that are being used by the functional heads to drive their uptime through of their assets, reducing any unplanned outages, through, and especially ones of critical equipment, and this can be done through a number of different categories of asset management software. We also look at process safety management software to stop work incidents and accidents, and other categories of software as well that can improve the productivity of workers within industrial facilities. Here are the 5 different categories of asset management software, which are covered in that Verdantix covers within our asset management research. So this is part of a recent report that I published, which was a market overview for the asset management software landscape, where we categorized these 5 different areas of asset management. And these are important. I'm going to deep dive into each of these in a second, but I just want to flag the importance of these, that these are, of course, the systems where the valuable data is being stored. So it's being collected either manually through workers' inputs, perhaps it's coming in through sensors or other systems, but then it's being housed in these, it's being analyzed through these. And what do we mean by each of them? So for asset information management, we're talking about the category of software that's being used, initially for maintaining the register of assets, but then also considering the different connections, perhaps within of pipes within a industrial facility. Also, how are those assets being used across their whole life cycle? So an important use case that's definitely emerging now is looking at something like an offshore oil rig, right from the stage of its design through to its construction, commissioning, operation, and as it's becoming more pertinent now than ever before, the decommissioning. Then there are asset maintenance technologies. So this is a broader spectrum. I mean, traditionally, of course, there were the CMMS software being used for the maintenance planning and scheduling. What's being included now much more in this category as well are things like maintenance analytics, so software to liberate and contextualize data coming from sensors or other systems into the asset maintenance system. Of course, the planning and scheduling, as I mentioned, of the work to actually, to audit or fix or repair individual pieces of equipment or parts. And then through to more frontline worker software systems, which things like field service management, where the frontline workers can have say on a mobile device, and it can help them with things like route planning. It can provide important information around the tasks that they're doing, and then they can also use it to collect information and send it back to the people sitting in the office. Next, you have asset performance management. This is really where the asset criticality becomes most important. So it would include remote monitoring of asset health, the analytics to flag when an asset is going to fail, and then included within that the criticality, so that the most vital pieces of equipment downtime can be reduced, if not removed, and then the overall performance of the asset can be increased. It's a vital component of things like reliability-centered maintenance. Going into asset investment planning, where the financial consideration of the assets is being taken into account, so that the operational and capital expenditure of the assets can be optimized. And then, as I mentioned, the process safety management, so the likes of control of work software, isolations management, job hazard analysis, and so on, which is being used. It was traditionally a separate category, but more and more what we have seen is that the functionality of process safety management is being used to ensure that maintenance planning and scheduling is done safely, especially through something like a control of work module, and that workers aren't hurt, and on the flip side, so that workers don't damage assets. Just an interesting point to this. So Verdantix every year does a survey of 200 or more senior managers across operations, maintenance, and engineering roles, and we always ask, what are the most important initiatives for you? What do you include within your operational excellence frameworks? And safe operations always gets flagged up as one of the most important for this. I think this year we had something like 93% including it within that operational excellence frameworks. And that really shows, the importance of process safety management for people in these functional roles, not only the people in EHS positions. And really, this market has developed over the last 20 years or more. Back in the 90s, there were the enterprise asset management systems, the ERP systems, the registers of equipment were kept on. And over time, what we've seen happen is that these have been integrated with other systems, so integrations with data lakes and warehouses to aggregate and contextualize data coming in from multiple different places, whether it's IT, OT, and ET, and also the implementation of those analytics that I mentioned. And then what we're really seeing going forwards, and I will get into this a bit more later on in what I'm going to talk about, but really it's foundational to the asset management software landscape. These categories of software are really foundational for achieving those sorts of value-added initiatives like a digital twin for an industrial facility, because things like asset information management is required to ensure that the digital data that's being used for a simulation will map to the real life assets. Right? It's vital to know that if if something's been moved, or even a new part of the facility has been built, that data is being captured and it's being reflected within the twin. And then also, of course, there are new innovations around things like artificial intelligence that are now also playing a greater role within the asset management landscape. And what we're really expecting to see over the next several years are more things like prescriptive analytics that can automate the planning and scheduling of work. And how is it that these categories of software that I've just been discussing can really be unlocked to add that value? I mean, we've heard, you know, I'm sure everyone listening to this knows of plenty of attempts by organizations to do digital transformation work, perhaps ones that have been done, you know, through in-house initiatives, attempting to build out their own software, that have not achieved the value add that they really wanted to achieve. And Verdantix last year did research looking specifically at this question. So we did a report on digital transformation, where we spoke to a number of different, you know, systems integrators in the market, vendors who work in this to get this best practice view. And from that, we got these 4 steps that are necessary for the value of the data to really be unlocked. So the first step is to assess the criticality, to classify each operational entity based on the financial materiality of asset reliability, to then consider the digital maturity of the firm, and to diagnose the state of technology infrastructure at all levels, to go into the change management, to assess the readiness of the organization to incorporate digital tools, and then finally to actually look at the value add. So what's the right size project scope to reflect the financial realities of each operational entity? And to put a bit more color on this is that to achieve the real value add, so to have, you know, to implement a say analytics within your organization to get more insight into the health of your assets, it's not just enough to go and work with a vendor. What happened, you know, I've spoken to plenty of engineers who have tried to do this. They get some new piece of software, they use it for a few months, and then it ends up just being shelved. Maybe they can't get buy-in from other senior executives, and so other people within the organization won't use it. And this of course means that to get those people to buy in to use it, they need to go through these 4 steps. Examples I've heard of how people have done this is to build the business case of that software across multiple different functions. And I will get into that a bit more when I talk about digital twins, where this sort of approach is really necessary. I want to look here at, you know, actually sort of how to consider this for the maturity of the technology and the financial materiality of the asset reliability, where, you know, every firm, as I'm sure you know, has their own level of technological maturity, which needs to be taken into account. If a firm is very technologically immature, it is less likely to be successful to suddenly try and go to the most advanced solutions. And also, of course, to get that buy-in, that business case that I just mentioned, the financial materiality of what's being undertaken is also very important. You know, if you want to implement a piece of software that can cost a few $1 million, you know, the whole implementation process could cost that. It wouldn't make sense to try and build a business case for that on an uncritical piece of equipment like a fan in a power plant. The business case just isn't there. So really, it needs to be considered based on this sort of matrix, where with the financial materiality is medium and the technological maturity is low. then really the first step should be to replace spreadsheets with maintenance software and add low-cost instrumentation. Then, as the financial materiality rises up, and so does technological maturity, you can start to consider things like implementing APM software and deploying proven analytics and workflows that deliver measurable business benefits. And then at the very top of this, if the financial materiality is very high and the firm is very technologically mature, you can consider doing things like optimizing asset management with using digital twins, which is really taking that APM to the next level, to not only have the analytics providing, insights into the health of the asset, but doing that in near real time with perhaps a 3D view, but as it's not necessary for digital twins, but perhaps with that 3D view of a whole facility. As I mentioned, getting into digital twins for industrial facilities. So there are lots of different types of digital twins. It is an evolving market. The earlier digital twins were started really within product design, but what we've come to see is them being used for whole industrial facilities, and this is the Verdantix definition specifically for that type of digital twin. And they are an evolving digital model of an industrial facility which replicates the facility's assets, processes, systems, and simulates its performance using real-time and periodic data to enhance operational decision-making. Within Verdantix, we've classified 5 different levels of digital twins, each of which have their own uses. So it's not a case that the transformative digital twins, the highest here, are the best. This really maps back to that, the financial materiality and technological maturity I was talking about a second ago. So, a descriptive digital twin would be a visual replica of assets, facilities, and products. This would really be a sort of a classic example might be a geospatial map of a facility that's been, built on top of the, the various different engineering diagrams that were used during the design phase, and perhaps is showing all of the live permits on a site. Then moving up to an informative digital twin, which is going to be actually having some integration with sensors and other systems to be pulling in near real-time data. And then this can actually, this level of digital twin will be providing insight into the health of whichever pieces of assets, say, that those that data is being pulled in from. Then the next level of digital twin is really, it actually includes those predictive capabilities. So being able to forecast, taking in that real-time data, and then based on those, that IT, OT, and now increasing the ET data integrations, being able to actually provide a more granular view in near real time and forecasting out when those assets are possibly going to break based on the analytics, the view of that data. So it could be, if the data's matching a past trend, failure trend, or something along those lines. The 4th level of digital twin is a comprehensive digital twin. So these would typically require physics-based models underpinning them using first principles. And these, would be typically, they will be taking in the real-time sensor data, using the analytics to provide insights into it, and then matching that with the first principles model, which would actually be able to provide simulations, more advanced simulations for failure, and then be able to do the likes of what if scenarios. So if we were to, if we were to increase output for a certain facility, how might that impact the degradation of a critical piece of equipment? And then also, as that real-time data is being combined with the first principles models, this can then make prescriptive analytics function properly. And of course, this will also then require actual industry expertise, understanding the, actually what are the recommended actions that need to be taken if some piece of a critical piece or part of a facility is, say, going to break based on the what if scenarios analysis. And then finally, a transformative digital twin is really we haven't seen any of these in the market. They're more a case of the thought leadership of people doing digital twin work, as opposed to something that is actually out there, because it would require a vendor agnostic integration with multiple real-time data feeds. It includes everything from the first 4 levels, but where the prescriptive has really been achieved using machine learning and AI. It would have a real-time 3D visualization of a whole industrial facility, and it would also be taking into account, or it would be integrated, with augmented reality or virtual reality. So these are the sorts of use cases people talk about, of being able to put on a headset in a boardroom to see how to show investors, say, how a facility is operating. To give an idea of really where some of the most advanced digital twins that I've seen in the market, the Jazan refinery by Saudi Aramco would be sat at a comprehensive, and that is one that had 11 or so different engineering firms involved, multiple systems integrators, and dozens of different software vendors and technology enablers underpinning it. And they spent billions of dollars on that over the last several years. Now, to achieve a implementation for a digital twin of industrial facilities, there are 5 different capabilities that are required from the vendor and from various partners in the implementation phase. So I'll go into these, but just before I do, just saying that it's very rare that any one vendor can or service provider can actually provide all of these, and it's much more typical within a digital twin for industrial facilities implementation that there will be multiple vendors involved. And the reason for this is data aggregation capabilities are required to actually integrate in the IT, OT, and ET data from the multiple different systems. There are a few different approaches here, but the most typical one would then be to actually have a data lake to have that data being integrated. Also, either the data lake needs to be able to contextualize the data, or there could be some other system for that contextualization. And what that really means, of course, is all the data that's coming in is coming in as zeros and ones, and it needs to actually, of course, be mapped against what's happening in the real world. Predictive analytics are needed the second the digital twin sort of moves into that 3rd level that I just described. And so this means that vendors need to be involved who can implement those analytics for key equipment and processes that can predict faults and future performance. And then to achieve the higher levels, so the 4th level and potentially the 5th level when we see it, asset simulation capabilities will need to be implemented as well. So this would be, actually being able to have the library of equipment information. So there's various different physics-based models of assets. And then going right back to what I talked about earlier, the model integrity management. So this, it relates to the asset information management I mentioned before, but this is to ensure that the digital twin will continuously map back to the real life asset. So as I mentioned, things get moved, new parts of facilities might get taken down, other parts might get built over the potentially the decades that it's used. And if that, when the digital twin is being built initially off old data, then as data gets fed in from sensors, it could be the case that where the model believes that sensors data is coming in from is no longer that location, and so that information needs to be kept, needs to be maintained. And then also there are various different systems for how that information the changes can be found. So there are cases of using drones to capture images, using the likes of Boston Dynamics Spot, and then of course using sensor data and other industrial IoT technologies. Talking about digital twins, of course, it can be quite theoretical. I've talked about these 5 different levels. I've talked about the different use cases for them, but here I'm showing this really to map out and show that the data for a digital twin, a more sophisticated digital twin, is really flowing in from multiple different locations. You know, it's there could be reference data, there could be IT/OT software integrations, as I've mentioned, sensor data, manual reporting, and of course other digital twins. You know, in many facilities, so especially within oil and gas and power utilities, a important connection within the process plant could have its own digital twin to be analyzing and identifying its degradation. There could be digital twins implemented for specific processes. You know, it could be, if it was a manufacturing plant, process simulation is quite widely deployed now. And so there are digital twins in place for specific bottlenecks within the production process. And so a more sophisticated digital twin of a whole facility will have integrations with those other digital twins to be able to pull out the necessary information. And then all of this will need to be moved into the digital twin to really be able to actually achieve each of those different levels of insight where necessary. And to really demonstrate the value that can be unlocked from this, this is from a market size and forecast that I worked on at the end of that I published at the end of last year, which was forecasting the digital twin for industrial facility market over the next 20 years. The way we did this was by looking at all the different, getting information on all the different vendors in the market. You know, what were their revenues for digital twins in 2020, and then using biologistic models to forecast out that growth over the 20-year period, and then basing that growth on actual insight from the industry. So talking to vendors, but much more importantly, talking to customers. So talking to the people actually using the digital twins and the type of value that they can get out of them. And what we're seeing right now is that the business cases for digital twins are not very well understood. And so the market is still relatively small at $800 million of spend in 2020 and $1 billion in 2021. But what we see happening over the next 10 years, up until 2030, when it reaches $6.5 billion, is actually that business case being built. So it goes back to that point I mentioned earlier about building the business case across different functions. So initially, perhaps it was a head of maintenance who can see the business case for having more insight into when assets need to be repaired. Then the business case could be built with a VP of operations who can see the benefit of having a view of you know, what could cause downtime for a whole facility. IT can be involved. They could see the benefits of having this sort of system, and then other people can get involved as well. You know, process safety, EHS. There are multiple different business cases that are being developed and demonstrated, and you can see this growth there. But then what we really see happening in the market in 2030 onwards is that the underpinning technological maturity will stop being a barrier. So as I mentioned at the beginning, there's a whole landscape of asset management software that is required to actually achieve a more sophisticated digital twin. And in many cases, especially in brownfield sites, they can't deploy the digital twins that they want, that they really can see the business case for, because they lack the technological maturity to get there. In 2030, that stops being a challenge, and then you can really see the market exploding up till 2040, when we expect it to reach $27.6 billion. Okay, I will hand it over back to you, Kira.
Okay, are you able to, I hope you can hear me okay. Just very briefly about Cognite. So what does data really mean for DataOps? For specifically, I'll start off with finding relationships in data and across data types, people and places, things and objects is an essential component of driving value from data and analytics. About Cognite is that Cognite is born from industry to improve data operations, which then helps to collect, connect, operationalize and scale use cases. We are currently at 424 plus employees globally. We have 9 locations around the world and growing. We've had an excellent partnership that started with Axel middle of last year as a VC partner to Cognite. We're working across 4 different industry verticals across oil and gas, power and utilities, industrial such as OEMs, and of course some shipping customers as well. We're also partnering with Microsoft, one of their top 200 ISVs, and of course Norway's first official Microsoft's global ISV partner. And very briefly, the way we position Cognite is that we're a leader in industrial data operations with IT, OT, and ET data contextualization at our core. What ET is engineering technology data. CDF is our core product, which is the industrial DataOps platform. And this is really built for SMEs, data scientists, to be able to have data discovery and provisioning at their fingertips. It is looking at all the different data sources from ET, which is the engineering technology data, OT is your operational technology data, IT is obviously your IT data, and that data contextualization along with ambient data governance, which goes from the data extraction level all the way to use case enablement and templatization for use case scaling. All of this is available within Cognite Data Fusion in the core software product. On top of CDF, we have a number of applications that are packaged, customizable business applications that are open, flexible, and these are open source libraries and therefore easy to collaborate and build on top of. So collaboration and partnerships with low code and dashboarding leaders as well. Open standards are everywhere to be found within Cognite Data Fusion, such as OSDU, and going through this list here that we have on the slide, and we will share the slides with you afterwards as well. So CDF is a data ops platform for data doers in the industrial sector. CDF is the acronym for Cognite Data Fusion, which is enabling heavy asset customers to be able to operationalize and scale their digital programs to unlock ROI at scale. And this is really looking at from the live data sources to where the data is then extracted, data is enriched, data is integrated, if there's data transformations, going to the various different pipeline orchestrations, contextualization orchestration within Cognite Data Fusion, where data versioning is happening, deployment, data monitoring, data quality monitoring, any anomaly alerting within CDF, along with equipment templatization, collaboration, governance, data discovery, and ultimately data visualization. These are the data principles that are available in Cognite Data Fusion as DataOps platform, as DataOps principles within CDF. So as I mentioned earlier, getting past industrial data challenges for operational excellence. I thought that we would discuss a few of these challenges today and really then talk about what Sebastian has discussed. What does that operational excellence really look like in the digital twin context? But I'll put it in with the Cognite context for you. But just very quickly, industrial reality is complicated. There are many different pieces of equipment. The industrial systems are made of components that are manufactured by multiple and many different equipment manufacturers that make it very hard to then manage the flow of data coming from these various different pieces of equipment. And especially into the advanced analytics and into the application layer, whether it's an application layer that you yourself as an enterprise, as a company are setting up, or whether it's an application layer that we as a technology services provider are providing you with. It does make it very difficult to be able to get that flow of data from these various different pieces of equipment into one place, to be able to connect it, contextualize it, and move it into enablement layer. And this is where it can take quite a long time to be able to get all of that data connected. The digital reality is, and those challenges are that most industrial companies have ran at least a handful of proof of concepts or MVPs, if you will, and most of those POCs can be considered successful, but they are standalone POCs that have been built manually. And then few of those POCs ever make it into production, and there's many different reasons and combinations of reasons for that. But one of the main pain points we see there is that because those POCs or proofs of concepts are very manually built, there's a lot of different stakeholders, and I'll get to that as well. So very few do make it into production or into scalable production, if you will, and very few POCs end up providing some kind of a substantial ROI by actually becoming those proofs of scale. And the industrial reality is, and this is of course most of the companies that we work with, and we see these as challenges in-house and working with Verdantix, and Sebastian has also alluded to this in his slides, is there is that OT, IT, ET data divide between these different divisions in-house. And then you also have the IT and data science divide, which is your IT data challenges combining with what the data scientists specifically need in order for them to be able to scale those models. There could also be poor data quality, for example. And then there is, of course, the data infrastructure is then fractured because of all these various different challenges. If those challenges didn't exist, you would be able to run POCs at scale, of course, and you'd be able to have more successful POCs, therefore actually having a more successful digital transformation transition as well. But what we're seeing is quite often that these POCs or being able to run use cases at scale, you wind up having a slow, expensive, or sometimes even a failed transition from being able to make it from POC to production. So what does a POC actually look like in-house that is very manual and not necessarily automated by using maybe perhaps an underlying technology that then allows for scale to exist is something like this. You've got many different stakeholders, 9 or 10 listed here. And then there are, just tons of manual check-ins with one another on quality of data. So that data quality monitoring is very manual as well. So you're not able to go from step one to the end enablement of a particular use case quickly without having these manual check-ins. And sometimes those manual check-ins can take months, it can take a lot longer. So time to value is also very, very necessary. Moving on to the next step. So industrially or IoT optimized data ops is needed for digitalization success. And that's where Cognite Data Fusion really comes in. So why does data ops matter for Industry 4.0? And crossing that chasm, if you will, is one, making information available. This is visualizing that existing data and putting it into context. Giving data that actionable advice from data extraction layer all the way to your use case enablement, where that POC or that use case ends up with your project manager or that data doer who will then go ahead and make data-driven decisions with it. And here you're able to enrich the existing data, create recommendation models with actionable advice. That is actionable advice in real time. And providing automation, which is really being able to automate that use case across other pieces of equipment or across fleet of assets, if you will. And this is being able to look at integrating models directly with selected systems that trigger automated actions. And what that really means is, if I go back to this slide here, you've now taken this POC, which is a lot of manual check-ins, to being able to have scale that allows you to have very quickly information that's available using the data extractors. Then you have data contextualization, which then allows you to give actionable advice. And then you have data enablement, which then allows you to have have automation. What does that actually look like in market context for Cognite Data Ops? Where we really fit in is industrial data management, combining that with data science, machine learning, and physics. and from the data extraction layer, also having digital twin solutions or putting that data into digital twin context at the same time, and ultimately enabling citizen ops, which is your low code application development. While Cognite Data Fusion isn't actually doing that low code application development, we are enabling low code and application development on top of CDF. And of course, on top of CDF, there is the application layer as well, out of the box application layer that Cognite does provide. And on the left-hand side in the pyramid, you'll see that some of the methods that are necessary to have in place for successful data ops delivery, that data delivery that's necessary for scale, for use case scale success, is AI governance, AI methods and foundations, and ultimately the use case enablement of the application layer. So what does data ops mean for heavy asset industry as an underlying technology? This is an image of process and instrumental diagrams in real time within Cognite Data Fusion. It is looking at making industrial data humanly understandable for operational excellence. It's being able to take all of this very complex data, putting it in a user interface that is easy to use, that is easy to understand, and you're able to kind of zoom in and out of this data, being able to make those data-driven decisions. So you're able to take your process and instrumental diagrams, you're able to create that PNID parsing in order to be able to look at your data now being connected. And the way that data is connected is that we use contextualization in Cognite Data Fusion. And I just wanted to very quickly touch upon contextualization, is that you'll go to be able to go from the source systems, which I keep referring to, is the extractors work with all the different data that's coming from the source systems, and those source systems using a number of connectors is put into a hybrid integration and data transformation service, and then that engineering technology, that OT data, that IT data is contextualized using a rule-based engine, a custom machine learning-based engine, and then some pre-built ML-based engines as well, where your document parsing, your entity matching, PNID parsing, data typing comes in, and then an industrial knowledge graph is created within Cognite Data Fusion. And this knowledge graph isn't necessarily different from what is already built in your enterprise or in your company or your IT and OT teams that work to build together. This is this data graph that we are building within Cognite Data Fusion is completely integratable within your own data knowledge graph. So it's not a separate data knowledge graph. And then this data knowledge graph along with yours, once those are fused, will then go ahead and inform all of your, using a number of APIs, SDKs, and through the Cognite Data Fusion GUIs, which is your user interface in CDF, are able to then show you all the data that is ready to now make those data-driven decisions by the data doers. And those data doers look like your developers, your data scientists, analysts, SMEs, partners, etc. So contextualization is about adding meaning through relationships and creating that active metadata. What does that actually mean? It's about creating all of that data has some context to it. Prior to that, data was probably together in a data lake. It was in various different historians, or it was, with various different equipment manufacturers. Data is now starting to be connected in one place using Cognite Data Fusion. And now that you've got all of this data in one place, it's got the entity matching, it's got all of your diagram parsing, it's got all the document parsing, the data templatization has been done, you've got all of your identity tags, similar objects, and all in one place, essentially meaning you're able to find all the different objects, and you're able to see all the data text patterns, if you will, in one place. You're then able to take those, take that contextualized data and now make data-driven decisions across different use cases that are necessary within your organization. And here's an example of how we use those use cases for upstream in oil and gas, for example, enabling the whole E&P value chain. This is just an example specifically for upstream, but this is very much a key example for downstream and midstream as well. that if you look at the business development challenges on the bottom of the screen, this is exactly how we would then take the digital twin context across whether it's manufacturing, factory floor, yield optimization within power, and really putting into context how your data will then be used across various different use case solving at scale. Just very briefly, I wanted to show you what it looks like to actually solve a digital twin use case, and all this data that I've just referred to and talked about, how is that data then actually put into action at Cognite? All of this data is used through Cognite Remote, which is one of our applications that sit on top of Cognite Data Fusion. This is just an example of one application using all of that contextualized, connected data through various different data sources that now will be used in CDF. So it's looking at activity planning, search and navigation, layers and filtering, measuring. Oh, let me just go back here. You should be able to see that video. Here you're looking at activity planning, which is really going into the asset itself, looking at search and navigation of the asset. And now you're able to go in and filter into a piece of equipment, valve or a pump, and you're able to also look at the layer and filtering here. Yeah, so now you're going to layer and filtering, which is looking at the details and the configurable access for the various different pieces of equipment. And you're able to zoom in into various different equipment. You're able to measure the accurate measuring directly. This is in live digital twin. You're able to measure. And then being able to look at that real-time data of a historical time series overlay of that particular piece of equipment. And really going into the visual inspection of the equipment, of the asset itself. And this is using photogrammetry, it's using computer vision, it's using robotics, drones, etc. And this is building out a fully integrated digital twin within Cognite Data Fusion. And you'll see that it's a little bit jumpy, only because we are on the webinar, but also here you're able to see that you're able to measure in real time and then go back into a piece of equipment again to be able to look at the different versions. And here you can see there's some corrosion happening, and then you can actually go back into Cognite Data Fusion and see what does maintenance look like for these pieces of equipment, or what is all of the different data that's connected to this equipment. And now we can just show you a little bit about how we capture that data with drones and robotics as well. I guess that was it for me, but we can take some questions if we have any.
There was one question, which was on, will we discuss the ROI on digital twins used in operations? Oh, Karen, if you want to start on that, and then I can pick up, or I can talk on it from a bit if you prefer.
It's an excellent question. I'll just pull up this slide here. Just go into to talk a little bit about ROI. I think it's an excellent question. How do you get to ROI with digital twin is being able to scale the various different use cases. And how do you scale those use cases is being able to make sure that all that data is available. And I think ultimately, when we speak about it from the Cognite data fusion context, we will always stress that the data story itself has to be a really strong data foundation in order to be able to solve any digital twin use cases, and ultimately to be able to scale those use cases, and therein lies your ROI. And what we see from our customers is that if we're able to look at scaling the data at 10x, you're also able to look at something like efficiencies at 100x. So it really does matter on what the visualization of, it does matter how the data is made available and what kind of data is made available and how quickly that data is made available. And then also giving that data that actionable advice, which is being able to enrich the existing data and then creating that recommendation models with actionable advice for the digital twin use cases. Sebastian, did you want to also try to answer it?
Yes, yeah, I'll add to what you just said, which is, of course, it also depends a lot on the type of industrial facility and the type of operations. I mean, it's digital twins are still new enough that it isn't a case of just going, well, this was the business case for them, so it'll be a similar business case for me. Considering, for example, I talked before in my slides about safe operations. There could be a business case there of perhaps if some digital twin capabilities have already been, or some level of digital twin technology has already been employed, perhaps there could be an operational ROI there from looking at factors that are impacting worker safety. Equally, of course, like Kieran just mentioned, it could be looking for operational efficiencies. One that has come up increasingly in conversations that I've been having, both on the buyer side, so with the likes of VPs of operations or heads of maintenance and engineering, is maintenance optimization. So being able to optimize maintenance activities in a way that they will have the least impact on operations. So this could be, of course, through using a digital twin to identify what are the most critical assets, and so when should we fix them. Equally, it could be if there is a simulation of production activities, which times are the best for planned downtime. So perhaps it could be dates of a month, or perhaps there is large orders planned, and so a digital a simulation of production activities would be able to provide insight into, well, perhaps we have 2 months before a piece of a conveyor within our production processes we're expecting it to fail. We have a large order in the next 3 weeks, and so the maintenance should be done after that. These are the sorts of considerations that really need to be done on a case-by-case basis to build out that return on investment model for a digital twin. Do we have any other questions, Karen?
I see that there's one more question that came in, is that, what are the benefits of starting a digital twin program? Sebastian, did you want to maybe start that one? Yes,
I can do. Well, it really goes to what I was just saying, actually. So, as I talked through, there are multiple levels of sophistication of digital twins, especially when we're talking about them for industrial facilities, and the benefits of those digital twins, of course, depend on what's they actually being used for. So if you remember that grid I showed, where the level of technological maturity against the financial materiality of the asset that's being managed, and what that really means is, when looking for the benefit of a digital twin, it could be perhaps wanting to consider the maintenance strategy of a plant. So being able to create a digital simulation and then do what if scenarios, and that can provide valuable insights into, if different strategies are followed, what are the different outcomes. So example, that this could be done, for instance, it could be looking at something like, if we maintain an asset every few weeks or every few months, what are the different costs going to be, both in terms of labor costs and in terms of the costs for failed assets. And then that could be considered, digital twin could be used to consider that for several 100,000 assets across a industrial facility.
There's another question, very good, Sebastian, thank you. There's another question on examples in which industrial service providers have adopted CDF. It's a very good question, and I think there's quite a few examples that I can just share with you verbally, which is that there is the industrial service providers, such as within oil and gas, we have quite a list of customers, and then we have within manufacturings, we have customers such as Technique FMC. I have quite a list, so I can always send you, this list will actually be posted within the slides. I went through it a little bit earlier in my slides as well. So across the different verticals, I would say is oil and gas, manufacturing, power and utilities, as well as a handful of customers in shipping. And we're also working in industries such as petrochemicals. So what I will do is I will post this, and you'll be able to reference this. And I think we are winding down to the end of our hour here today. Thank you again all for joining us. And if there's no more questions, we'll go ahead and sign off. The webinar will be available on our website for everyone to be able to look at. The presentation itself will also be available so that you can download. And if there's any questions at all, please do send them over to sales@cognite.com, or you can also find me on LinkedIn, and Sebastian is also available on LinkedIn as well. And please do reach out to us if you have any questions at all.